Hi, I'm Tina Bongar from the Stop Holtec Coalition, and I want to thank the individuals who are part of our coalition and our co-sponsors for this interview today, Grassroots Environmental Education and Food and Water Watch, and all of the individuals who've supported this effort. And this is an interview with nuclear engineer and expert Arnie Gunderson. So welcome, Arnie. And can you let us know a little bit about your background and credentials?
I went to Rensselaer up in Troy, New York for 5 years, got a bachelor's and master's in nuclear. But what's important for this discussion is that I was in the sailing club and we used to race on the Hudson River. So I can attest that the tides frequently were pushing the boats back faster than the wind was pushing them down. So I'm aware of the tidal nature of the Hudson River. Got 2 nuclear degrees, cum laude, and on a AEC fellowship. Got a reactor operator's license while I was at RPI. Little known fact that RPI owns a nuclear reactor in Schenectady on the Mohawk River, which eventually drains into the Hudson. I have a safety patent, 3 peer-reviewed papers. I wrote a best-selling book on Fukushima. But what's important here is that I was a senior vice president in the nuclear industry working for a dismantlement contractor, a decommissioning contractor. In fact, I wrote the very first decommissioning handbook back in, I hate to say it, back in 1980. So in Vermont, I was the chair, the
How
first
would we
chair
go about
of the oversight panel that the governor put together on Vermont Yankee in 2008, 2009, 2010. So that's it in a nutshell.
Arnie, how would you go about handling the temporary on-site storage now of the 1.3 million gallons of fuel pool wastewater that we have at Indian Point?
I was the senior vice president in charge of a couple hundred engineers. And one of the things we did was dismantle power plants like Shippingport and other facilities. And I've also been keeping careful track of a similar power plant to Indian Point, the Zion nuclear plant out in Michigan, and watching its progress to become dismantled. And the experience at Zion is critical to what's happening at Indian Point. When you look at Indian Point, there's these domed shaped buildings, and that's where the nuclear reactor is. That's the nuclear containment. It's predominantly a vertical structure. And then along the river, there's a horizontal structure. It's brick, and that's the turbine hall. Inside the turbine hall is non-radioactive. None of the pipes, none of the major components in there are have any radioactivity. The radioactivity is in the containment, hence the name containment. And what they did at Zion is exactly what could be done at Indian Point. They gutted the inside of the turbine hall. They took all these heavy metal components out and sold them for scrap. So the turbine hall is actually a profit center. And if you think of it, it's probably as big as 8 to 10 indoor tennis courts, maybe even 12 indoor tennis courts. It's a huge building. And what I would do based on all the experience I had in life is to take all those components out, sell them for scrap, and make some money. Make a lot of money, probably 50 or $100 million worth of scrap metal in that facility.
Oh.
Zion made money on their turbine hall. So that would leave you a huge building with an incredibly strong foundation that you could put tanks in to store the radioactive water that Holtec had been planning to release.
Arnie, in our pre-discussion, you mentioned that the turbine buildings may be a place for the radioactive water tanks to be stored. Um, does the NRC have jurisdiction over that?
Vermont Yankee over in Vermont, which is another plant that's being dismantled, um, in the basement of its turbine building, put bladders, put tanks in the basement of their turbine building to store radioactive water that had lots of tritiated water in them. The
Okay.
lay word is tritium, but it's really tritiated water.
Yeah.
So Vermont Yankee stored tritiated water in the basement of their turbine hall, and they didn't need an NRC permit, and they didn't need a town permit. It was a simple process of they had radioactive tritiated water. They needed a place to put it, and they stored it in rubber bladders in the basement of the turbine hall. So the storage of liquids like radioactive water in
Yes.
turbine halls has already occurred less than 200 miles away
Yeah.
by another decommissioning contractor by North
Great.
Star. Um,
Yes.
but the
Yeah.
concept is the same. That structure is strong enough and substantial enough and large enough that tanks can be installed without any NRC approval and without any town approval.
Arnie, there's been a lot of talk about the use of bladders, inside tanks, outside of tanks. Anyway, for bladders to be used for the storage of this radioactive wastewater. And in that, there was some concern, and there is concern about the concentration or evaporation of this concentration of tritiated water. Would you mind telling us about that?
Bladders are independent of tanks. They're a quick tank, really not made for extended service like may occur at Indian Point. So it's an easy thing to build quickly, but if there's any idea that you're going to keep it for years or decades, I wouldn't recommend bladders. But let's look at Fukushima. Fukushima has 1,000 tanks that they've built over 10 years. So they're building 100 tanks a year or a tank every 3 days. So it's not hard to build a tank that holds tritiated water. It comes in segments. If you look at the Fukushima pictures, they come in segments, and those tanks have leaked very little, if at all, in 10 years. So what I'm proposing is to bring in segments and build a Fukushima-sized tanks. 5 of them would be all it would take to store 1.3 million gallons of water. And after the tank is built, it's going to be in pieces, so there'll be seams, and then it gets a rubber liner in it. Now, a rubber liner is different than a bladder, which is sort of a free-form piece of rubber, and so you wouldn't build a steel tank and then put a rubber bladder inside it. You'd build a steel tank and then line it with a rubber liner, which is a pretty common industrial way of storing liquids. Now, the other thing you asked about.
I'm sorry. Yeah, I'm sorry to interrupt you, Arnie. You're probably going to address it, so I apologize. So go ahead. It's the evaporation, isn't it? And yeah, great. Thank you.
The other thing is people on the other side of the argument that don't want to build tanks are claiming evaporation is a big deal, and it's simply not. Again, I had teams of engineers who did things that others said couldn't be done, and a couple of weeks with 5 engineers and we could solve this problem at storing waste in the turbine building. So first, gut the building, get down to the foundation, and put up 5 tanks inside. Now, tanks are vented on the top, and the reason they're vented on the top is so that as the water height changes, the from either temperature changes or from water being added or being pulled out, so the tank doesn't collapse. Um, but that's not what we have at Indian Point. We've got a static tank. You're going to put a couple 100,000 gallons in each of these tanks, and the water's just going to sit there. And it's going to be in touch with the floor, which is probably at maybe 60 degrees and relatively stable. So temperature changes in the water are nominal. Now, there will be a vent on the top of the tank. So as you're filling it, the air in the tank will leave it and the water will come up. And also eventually when you drain that tank, you want air to come in and replace the water so the tank doesn't collapse. But in the meantime, in between those two times, in between filling it and draining it, evaporation is nominal. And you could even prevent any evaporation by putting essentially a rubber balloon on top of the tank, so that as the volume increased, the balloon would swell as the air got displaced, and as the volume decreased, the balloon would shrink as pressure pushed it down. You could keep easy track of the contents of the tank. The other part of that argument that is doesn't make scientific sense is that water evaporates faster than tritiated water. Tritiated water is heavier than water, so that if a tank evaporated, it would be the water that would be leaving and the tritium would stay behind. There's a couple degree difference in the temperatures to evaporate water off. So the normal evaporation will actually increase the tritium levels in the tank and put more water vapor into the air. But I don't think you need any of that. You can simply build a tank, put a vent on the top, and then put a rubber balloon over the top that expands and contracts as the temperature changes in the tank. It's not like you're going to heat this tank. It's going to sit at 70 degrees for years or decades. So there's not going to be a lot of volume change. But whatever is in it could be collected in that balloon and would just drain right back into the tank. I don't think it's a difficult engineering problem.
What materials, Arnie, do you recommend to use to construct the storage tanks?
Lined stainless steel tanks are fine. I've seen some tanks that are lined with a metal clad. I don't think that's necessary. I think a rubber liner inside the metal tank would be more than adequate. And the question is, how long will the tanks be there? And a tank is not going to fail catastrophically. It may start to leak over time, and based on the Fukushima experience, you could, instead of having 5 tanks with water, you could have 6, one of which is empty, so that if a tank were to leak, you pump the water into the fresh tank. It's just not a problem. Yet again, remember how big this building is. This building is as big as a half a dozen to a dozen indoor tennis courts. It's huge once all these components are removed, and removing the components makes money for Holtec. So it seems to me to be a win-win. How long the waste is, the radioactive water stored there, is a separate problem, and that really depends on what's really in that water.
Arnie, this is a question that came up recently. Is it possible to use the tanks that have been used to store the borated water on site for the storage of the tritiated water instead?
There's 4 sources of radioactive water on the site, each fuel pool, and then there's a couple of borated water tanks as well. And they're large. They're as large as the ones that I was posing in the turbine hall. There's no indication that those tanks ever leaked over over their 50 years that they've been in service. And in theory, you could continue to keep using those borated water storage tanks to store water in. But it's a simple issue. If you didn't want to do that, you can move it into the 5 tanks that I'm proposing. The total volume, this 1.3 million gallons, is just about that includes the 2 fuel pools and the borated storage tanks, so that it's not a big deal. Those tanks already have a history of working just fine. So if you wanted to consolidate all of it in one location in the turbine hall basement, you could do that. If you wanted to consolidate the spent fuel pool water in the turbine hall basement and keep the borated water elsewhere, you could do that. I don't have a dog in that fight.
Well, this is a good pivot point to our second set of questions regarding the proper characterization, testing, and sampling of the wastewater. Do you have a recommendation as to how this should be done?
This is not pure water, and it's certainly not just tritium in the water. This has been in contact with nuclear fuel, which leaks over time, and particles of nuclear fuel or other radioactive fission products, the radioactive rubble left after the fission occurs, are going to be in that water. They likely will have preferentially moved and lightly attached themselves to the walls of the pool. And so as the water is agitated, the radioactive fission products that are either in the water or on the wall are going to come off. I'm really dissatisfied with the work that Holtec has done to characterize the water. Essentially they drew some water out of the center of the pool and said, this represents a homogeneous collection of 1.3 million gallons. And I don't believe that to be true. To do it right, what you'd need is maybe 10 samples in each tank and in each fuel pool. I take a couple samples from the water column and a couple samples with something like a vacuum cleaner off the sides and the bottom of the fuel pool. Some of these particles are heavier than water and will sink or gravitate into the corners. And as Holtec cleans that pool out, they're certainly going to be disturbed, and they're certainly going to be pumped into the Hudson if that's what they had planned to do. So you got to find out what's in those pools in a more comprehensive way than what Holtec did. So what I'm proposing is essentially suctioning out water at different elevations in the pool. The pool's 40 feet deep, so something near the top, something near the middle, something near the bottom in the water column, as well as near the sides with some kind of a vacuum cleaner, and on the bottom, again, with some kind of a vacuum cleaner, and in the corners, again, with some kind of a vacuum device, essentially a shop vac, that's designed to pull water up in liquid conditions. So I think you're looking at, 30 or 40 samples total, but taken at different locations in the pool and analyzed in a reputable lab that we all have confidence in.
Arnie, can you discuss independent labs and the importance of those in getting a real independent sampling of the radioactive wastewater?
There's several independent labs out there that frequently examine water, radioactive water or water that has chemical contaminants. And by and large, the 2 or 3 or 4 of them are comparable in quality and trustworthiness. In other words, they're not in the pocket of the nuclear industry. You could also do blind samples, which they'd have no idea where the samples came from. It's just a group of people sending a sample, so that there could be no citizen, no, so that there could be no industry pressure on the lab to come up with a correct answer. Fairwinds and our associates have done these kind of tests pretty routinely, and there's a few licensed laboratories that are independent and competent, and the choice of what radioactivity, what type of radioactivity might dictate which lab you use, but it's a little premature to know that now until we get a little further into the process.
Could you just, I mean, take a stab just briefly with an overview of the treatment, some of the treatment that would be entailed in some of these radionuclides that may be in the wastewater before they go into storage?
The water in the borated water storage tanks and in the spent fuel pool has already been filtered and demineralized. So a demineralizer is 90+% efficient at gathering the radioactive material, so that the systems they use at Fukushima are really designed for a witch's blend of chemicals that don't really exist in Indian Point, because Indian Point didn't have a meltdown. So the system at Fukushima is not appropriate. But those systems, those filters, and those demineralizers exist at Indian Point, and are perfectly capable of continuing to reclean that water 2 or 3 more times to make sure you've got every last bit of it. If the first time gets 90%, which is where those are now, the next time we'll get another 90% of the 90%, and your 99% of the particles have been removed. But there's a lot of particles, so that's probably not enough. Another pass through that filter and demineralizer will be necessary to get the residual radioactivity. Those filters then are radioactive. So as the water becomes less radioactive, the filters become more radioactive, and that gets shipped to a disposal facility. And there's a couple of them in the United States that take those radioactive filters.
Arnie, would you like to add anything here about synergistic toxicity?
I think one of the great things about Governor Hochul's decision not to dump the stuff in the river is that the Hudson River is already contaminated with PCBs. And there's this phenomenon in science called synergistic toxicity. It's a cool sounding term, but basically you've got a toxic substance in the dirt at the bottom of the river, and now you're adding another toxic substance with tritiated water, and the combination of those two toxic substances is worse than just adding the two together, and that's called synergistic toxicity. PCBs have hydrogen sites, and if a hydrogen atom gets replaced with a tritium atom, worse than PCBs are tritiated PCBs. So it's important that the people up and down the Hudson realize that Governor Hochul's decision is not just preventing the release of tritiated water, which Holtec will say is not a concern. It's releasing tritiated water into water that is already contaminated with PCBs. That combination is not linear. That means it's worse than the two combined. So my hat's off to New York State for recognizing that.
Arnie, is there anything else you would like to add that's very important for us to know about at this point, like where we are after the governor has signed the bill?
Well, the state's process of examining the water prior to release is totally inadequate for the reasons I talked before, where you need to do more sampling than the state was planning on doing. So their concept of how to sample the water is inadequate. Where to send it to is the other question, though. I'm sure the state lab has competent people and competent procedures, but they don't do this every day. And the independent labs that we work with are in the business of routinely measuring radioactivity, quite likely in lower concentrations than the state lab is capable of. So I don't mean to knock the state's technicians or its laboratory facilities, but it's one thing to throw a sample in a detector once a month, and it's another to be doing those on essentially a daily basis. The technicians and the equipment at the independent labs that are out there, just do more of it. And when you do more of it, you get better at it. And likely they have lower limits of detection too. So we'll get a better idea of what's in that waste if we went to an independent lab.
So, Arnie, thank you so much for this interview about these specific topics that are important to us right now. And so, on behalf of the community, Stop Holtec Coalition, and all of us, thank you for your time.